Hi guys, this is Dr. G here, and in this video we will continue our discussion on ionic compounds. And also in this video I will discuss how to write formulas for ionic compounds. So in a previous lesson we learned that ionic compounds contains ions, right? So these ions are of two types. You have cations that were made up of metals, and then anions that were made up of non-metals. And cations are positively charged, anions are negatively charged. And these opposite ions are attracted to each other through electrostatic interactions, and we call them ionic bonds. These ionic bonds are very strong, and also the arrangement of these ions are usually uh, a very organized crystal lattice. It's a 3D crystal lattice of ions that is given in this figure. So because of this 3D crystalline structure of ion lattice, and also because of the strength in ionic bonds, ionic compounds have very high melting points. And because of that, ionic compounds tend to be solids at room temperature. Also, we learned about some of the common anions and cations that we could find in ionic compounds. Especially, we talked about cations that were made up of metals from group 1A, group 2A, and group 3A. And also, we talked about anions that were derived from non-metals, especially from groups 5A, 6A, and 7A. And also we learned how to figure out the charges of each of these cations and anions. So basically at this point, I expect you to understand how to figure out the charge of each of these cations and anions. All right, let's talk about formulas of ionic compounds. So basically, formulas of ionic compounds provide the lowest whole number ratio of the ions involved. Okay, it provides the lowest whole number ratio for the ions involved. As an example, let's talk about this ionic formula for aluminium oxide. Okay, so you can clearly see that it has the aluminium symbol and oxygen symbol, so you know that it is made up of aluminium ions and oxide ions. Okay, so basically it will tell you what type of ions are involved. So it has aluminium ions, and we know the charge of aluminium. It has aluminium ions and then oxide ions. Okay, so based on the symbols we can figure out which type of ions are involved in this chemical compound. And also this subscripts or this coefficients basically tells you how many aluminiums and oxygens you have. So in this chemical formula you have two aluminium ions, you have two aluminium ions, you have two aluminium ions, and you have three oxide ions. Okay, so according to this chemical formula, it has two aluminium 3 plus ions and three oxide ions. So that's the information that we get from a chemical formula. It basically provides you the ratio between aluminiums and oxygens, and this is the lowest whole number ratio for aluminium and oxide. All right, so the other important thing is, if you take a look at the charges of ions that are involved, okay, so you have two aluminium ions. Aluminium ion is plus 3 charged, aluminium ion is plus 3 charged, and then you have two of them. So we have a total of plus 6 charges. Okay, the total charge is plus 6. And then if you take a look at oxide ion, the charge on oxide is minus 2, and you have 3 oxide ions, so the total charge is minus 6. Okay, so as you can see, when an ionic formula is accurate, okay, if the ionic formula is accurate, the cation charge or the total positive charge should be equal to the total negative charge that comes from the anions. Okay, so the total positive charge should be equal to the total negative charge. That is the whole purpose of writing chemical formulas for ionic compounds. So the total positive charge should be equal to the total negative charge. So the chemical formula should have the total positive charge equal to total negative charge. This is the whole purpose of writing formulas for ionic compounds. Next, we are going to learn how to write ionic formulas. Okay, so let's say we have a metal cation called M plus. Okay, so we have a metal cation called M plus, and I'm going to color it in let's say red, or I'm going to color it in red. So the metal cation is M plus, and then we are also going to have a non-metal anion called N minus, and I'm going to color it in a different color. Let's use blue. Okay, so our non-metal anion is blue in color. Okay, so we are going to write a chemical formula for these two ions. Okay, so what we do here is that we are going to write the metal element first. Okay, don't worry about the charge yet. Okay, write the metal element first. Okay, so M comes first, and then next to it you will write the non-metal element, which is N. Okay, so let's color them again so that you will not get confused. Then metal will be red in color. Okay, and then these charges also have a function. So what we do is we are going to swap the charges. And write the charge of non-metal as a subscript for metal. So N comes as a subscript for metal, and then M comes as a subscript for the metal. Okay, so we use the charges as the subscripts that we have in the chemical formula, which basically tells us the ratio of the anion and cation. But when writing these charges, we don't use the sign. We do not use the sign of the charge. We don't worry about whether it's positive or negative. We only need the numerical value, and we swap them and put it next to each other. Okay, so that is how you write the chemical formula. Okay, chemical formula. All right, so this is our chemical formula. So let's take a real-time example. Let's write aluminium sulfide. Okay, so let's use aluminium and sulfide. Okay, so sulfide has a -2 charge. You should know that now, right? Aluminium has a +3 charge. Okay, so what we do is when writing the chemical formula, we write the metal first. Okay, and then we swap the charges and take the charge from the non-metal, which is 2, and you put 2 here, 2 next to aluminium. Okay, you put 2 next to aluminium, and then write the non-metal ion, and then take the charge from the metal, okay, without the sign, and write it as a subscript. Okay, write it as a subscript, so it will be 3. Okay, so this is how you write a chemical formula for the two ions between aluminium and sulfide. Okay, the chemical formula will be Al2S3. Okay, so Al2S3. This is the final chemical formula. And let's check whether it is correct. How do you check whether it is correct? Because we know that if the formula is correct, the total positive charge should be equal to the total negative charge, right? So this side is the positive side because you have the cations in this side and you have the anions in this side. So if this aluminium sulfide formula is correct, we should have the same number of positive charges to negative charges. Okay, so the total positive charge should be equal to total negative charge. So for aluminium, we have 2 aluminiums. Each aluminium is a +3, so 2 times 3 is a plus 6. So we have plus 6 on the cation side. And then for anions, we have 3 sulfides. We have 3 sulfides, and sulfide charge is -2. So 3 times -2 is how much? 3 times -2 is plus -6. 3 times -2 is -6. Okay, so cations gives us the total positive charge, which is equal to +6. Anions gives us the total negative charge, which is -6, and they are equal and opposite. So the overall charge is 0. Okay, so the total positive charges are equal to the total negative charges. So therefore, the overall charge will be what? The overall charge will be 0. Okay, the overall charge will be 0. Overall charge is 0, which means ionic compounds are neutral. Okay, if you have the same number of total positive charges to negative charges, then it should be a neutral compound. Okay, let's take another example. Let's try calcium chloride. Okay, calcium chloride, Ca 2 plus is calcium ion. You know that it is 2 plus. Why? Because calcium is in group number 2a, which means you have 2 valence electrons. Number of valence electrons is equal to the group number, right? So calcium has 2 valence electrons. So in order to achieve the noble gas configuration, it is easy to remove 2 electrons, right? It is easy to remove the 2 valence electrons. It is easy to remove the 2 valence electrons. So you are losing 2 negative charges. So therefore, you will be 2 plus. Or in other words, initially the proton to electrons were equal, but after removing 2 electrons, you have 2 protons in excess. So protons are positive, so you have 2 protons in excess. So therefore the charge will be a 2 plus. The charge will be a 2 plus. Okay, so that is how you figure out the charge of calcium if you don't know it yet. Okay, but I highly recommend that you guys watch the video on anions and cations, so that you will have a proper understanding on that. Okay, our negative charge is chlorine or chloride, and it is a -1 charge. Why is it minus? Because it is in group number 7a, which means it has 7 valence electrons. So in order to achieve the noble gas configuration, you just have to get one more electron, right? So if you are getting an electron, you are getting a negative particle. So you have 1 electron in excess, right? So if you have 1 electron in excess, your charge will be a -1. Okay, a -1. So let's write the chemical formula. So when writing the chemical formula, we first write the cation. Okay, and then we swap the charges. And then chlorine has a 1, so put 1 as a subscript. And then you write the anion, chloride, and then chloride get the number 2, right? The chlorine symbol gets number 2 from calcium, so it will be 2. Okay, so the chemical formula will be Ca1Cl2. But here's the thing, I mean, we usually don't write 1. Why? Because I mean, we already know that it has calcium. Okay, if you have only 1 calcium, you don't have to say that it is Ca1. Everybody knows that it is 1. Okay, so it is not traditional to write the 1. Okay, so if it is 1, don't write it, but if it is any other number, write it. Okay, so this is our chemical formula. Let's check the accuracy. Of our formula. Calcium chloride. Okay, let's separate the positive side from the negative side. Okay, so we are separating the anions from the cations. Cations are positive, anions are negative. Okay, anions are negative. So in here you have only 1 calcium ion, which means you only have +2 charge in the cation side. Okay, total positive charges that you have is +2. And you have 2 chlorides, 2 times Cl minus. Okay, so 2 times -1 equals -2. So as you can see, the cations to anions, they will balance each other. The total positive charge is equal to the total negative charge. So therefore, the overall charge is what? The overall charge is 0. So this is a neutral compound overall, right? So the formula is correct. The formula is correct. All right, so next up, what I'm going to do is I'm going to write a bunch of different uh, elements. You will figure out the charge, and of course you will also write the chemical formula. Okay, so I have six questions for you to try. So what I want you to do here is that I want you to figure out the charges for these cations and anions. Okay, you have to know them. Okay, you have to be able to figure out the charges by looking at the group number, and then you will write me the chemical formula. Okay, so you might want to pause the video and then try it out by yourself. Okay, and then in a second I will start explaining them. So pause the video now. So the first compound that you have is between sodium and fluoride. Okay, sodium charge is +1. Okay, and then fluoride charge is -1. Why? Because sodium is in group 1A. Sodium is in group 1A. It has one valence electron. So to achieve the noble gas configuration of neon, it will kick out the valence electron. It will kick out the valence electron. So you will have one proton in excess. Protons are positively charged. So the charge will be a +1 for sodium. Okay, so fluoride is in group 7A. It has 7 valence electrons. So only need one more electron to achieve the noble gas configuration. So once you take one electron, you will have one electron in excess. Okay, one electron in excess. So your charge will be a -1. If you don't understand that, okay, let's say you have 9 protons and 9 electrons in the beginning. Okay, but after taking one electron to achieve the noble gas configuration, you will have 10 electrons and 9 protons. Okay, 10 electrons is what? 10 electrons is -10. 9 protons is +9, right? So you add them up, and then the overall charge will be what? The overall charge will be a -1. Okay, so that is how you calculate the charges. I'm not going to explain all these questions like that, but this is the last time. Okay, all right, so let's write the formula. You will write the metal cation first, and then you swap the charges. They are both 1. Okay, both 1. I mean, even though you can't see it, it is 1. Okay, we don't write 1, just write the charge. Okay, it is not conventional to write the number 1. Okay, so sodium gets number 1, but we don't put number 1 as a subscript. Okay, by writing the element symbol, you know that you at least have 1. Okay, and then fluoride also gets the 1, so don't write 1. So the chemical formula, the ionic compound formula will be NaF. All right, next up is magnesium and bromide, Mg2 plus Br minus. Okay, so the chemical formula, magnesium, you will write magnesium first. You swap the charges. So magnesium gets the number from bromine. So it is a 1. Don't write it. It is a 1. Don't write it. Bromine gets number 2, right? Bromine gets number 2. So Br2. Magnesium bromide, MgBr2. Okay, next up is aluminium oxide, Al3 plus O2 minus. All right, so first write the metal, which is Al, and then swap the charges. So aluminium gets number 2, so put 2 as a subscript, and then oxygen, gets number 3 from aluminium. Okay, so the chemical formula will be Al2O3. So these are the answers that we got. Okay, and next up is calcium oxide. This is a curious one. Okay, pay attention to this one. Calcium is +2, oxide is 2 minus. Okay, and then you write calcium first. Calcium gets a number 2. I mean, you swap the charges, and then calcium gets number 2 from oxygen, and oxide get number 2 from calcium, right? It is Ca2O2. But here's the thing. When we are writing the chemical formula, I told you, we take the lowest ratio for atoms, right? We take the lowest ratio for atoms. So 2:1 is like 1:1, right? Sorry, 2:2. The ratio between calcium and oxygen is 2:2. 2, right? So 2 to 2 is basically the same as 1 to 1, right? So rather than writing 2 to 2 to 2, you can write 1 to 1. So we don't write 1, right? So you can leave calcium oxide as CaO, okay? All right. So next up is, this is important, okay? Just remember this one. Just remember this one, because this is the first time that I mentioned that, okay? If the charges are equal, for the anion and cation, so they will basically cancel out each other. So you don't have to swap the numbers. It is just one, okay? It is just one. Why? Because we are worried about the lowest. We are worried about the lowest ratio of anions to cations. So 2 is to 2 is the same as 1 is to 1. Is the same as 1 is to 1. Okay. All right. So next up is potassium and nitrogen. Okay. So K plus and N3 minus. You write potassium first, and then potassium gets number 3 from nitrogen, because you are swapping the charges. And then nitrogen gets number 1 from potassium. So don't write it. Here's the chemical formula. Okay, last is strontium and chlorine. Okay, so strontium is a plus 2. Okay, it's a plus 2. It is in group 2A. Chloride is a minus 1. Okay, so the chemical formula will be Sr gets number 1, so don't write it. Sr gets number 1 from chloride, and then chlorine gets number 2 from strontium. Okay, so it is SrCl2. All right, so that is how you write chemical formulas. But let's learn how to write the names of these ionic compounds. We know how to write the chemical formulas. So how do you write the names? How do you write the names for these ionic compounds? Let's learn that next. So when naming ionic compounds, it is actually very straightforward. Okay, it is very straightforward. You will write the cation name, then you will leave a space, and then you will write the anion name. You will first write the cation name, leave a space, and then write the anion name. Okay, anion name. As an example, let's talk about our Ki. Let's talk about Ki. Okay, so in here you have a potassium ion. Okay, in here you have one potassium ion and one iodide ion, right? So the name will be potassium. Okay, so the name will be potassium and space and the anion name. Anion name, how do you write the anion name? You take the first few syllables of the non-metal name, and then you add ide to the end, right? Ide to the end. So this will be potassium iodide. IODIDE. Okay, iodide. Okay. Then you can try to name the 6 compounds that we learned before. Okay, so keeping that in mind, you can try to learn the compounds that we learned before, and also keep in mind, okay, your ionic compound name will never change based on these coefficients. Okay, doesn't matter what the coefficient or the subscript is, it doesn't change the ionic compound name. All you need is the name of the cation, space, and the name of the anion. Okay, so let's try the first one. You might want to pause the video and try it by yourself. Okay, and then see if you are correct. Okay, so I'm going to use a different color. So this is sodium, then fluoride. F minus is fluoride, right? So next up is magnesium bromide. Okay, the metal cation name is magnesium. Then bromide. The third one is aluminium oxide. Okay, aluminium oxide. It is never dialuminium trioxide. Some people have some some knowledge from chemistry from maybe high school or somewhere else, and sometimes they learn chemistry by themselves, and then they might pick up some bad habits. Okay, I have seen many people say that, okay, this is dialuminium oxide, I mean trioxide, or things like that. That is wrong. We never focus our attention to these coefficients. Okay, we never focus our attention to these subscripts. It is just the cation name followed by the anion name. Okay, so you can try these three. I will post the answers in a second. All right, so I have written all the answers for the 6 compounds that we studied in this video, so you can check whether your answers are the same as my answers. So with that, I'm going to conclude this lesson. Okay, and I will see you guys in a next lesson on ionic compounds, and in that video we will talk about cations with variable charges. Okay, not all the cations are going to have a fixed charge. Some metals can have multiple charges. So we will talk about these ionic compounds that contains cations with variable charges in our next lesson. Okay, please let me know if you have any questions. You guys have a good day. Take care.